Thank you, Joe. I can't claim I was doing continuous integration before it was called that. I might be able to claim I was doing continuous delivery before it was called that. I also do live in Brooklyn, which, for those of you that don't know, is the hipster capital of the universe. It's not Shoreditch, so I have to say something hipstery, despite the fact I can't grow a beard. Thank you, everyone, for coming along, and I hope you are having a nice, easy after-lunch experience. And thank you also to the folks that are here that came to my training yesterday, who are gluttons for punishment and want more of me. Thank you. So yeah, continuous experimentation. I had no idea that Linda was going to give the keynote that she gave this morning, but she did, and that was wonderful, and she's come along this afternoon as well. So now I'm going to feel like I'm getting even more of this wrong. No, this is a talk that I've been sort of mulling and working on over a while now, with some interesting thoughts. Before I get into that, though, there are quite a few quotes in this talk, and they are all referenced at this link. I'll put this URL up at the end, and so if you're interested in some of these things, then this link and the one at the end is the one you need to take a photo of. But I do use more quotes than I normally would in this one. As Joe said, I work for a company called Symphonia. I am half of Symphonia. We are a cloud architecture consulting business. Despite my accent, I live in New York. I've lived in New York for 12 years. And sort of this is what we do for folks now, which is a lot of fun. We've been doing this for about a year and a half, myself and my business partner, John Chapin. Trying not to knock my mic off. So continuous experimentation, what is this? So I've been part of the software industry now for 20 years. And in that time, I used to work at ThoughtWorks a long time ago, and I worked with Dan North and a bunch of people like that, Jez Humble. And so there's this whole like Agile and DevOps and continuous delivery and all this stuff. It's sort of all been rambling around in the circles of which I inhabit for a while now. And part of what we've seen over these 20 years is that the lead time for delivering software has come down significantly. So it used to take years. You know, the first projects I worked on were 18-month projects, right, to get sort of the first delivery out. And now we see it's more like weeks or so to get a delivery out, which is a drastic improvement. But I'm actually seeing now that we have the opportunity to bring this lead time down even further to days or even hours. And I think that this can transform the way that we think about delivering software to one, instead of being a big, long factory and production line, to being one much more oriented around experimentation, around some of the ideas that Linda was talking about this morning. But what advantages does thinking about this way of delivering software give us? And what are some of the challenges that we might hit in trying to do this style of work? So these are some of the questions that I want to bring up, and then hopefully try and answer a little bit during the talk. So I want to start off with a little bit more of this journey of what I've seen over the last 20 years of where we've come from this sort of really, really long lead time to something much, much shorter. Before I talk about that, though, I want to get a little bit philosophical. What is the point of software engineering? This is not a question that we tend to ask very often. We're heads down in our work. We're coding or managing. I do a little bit of both in my career. But it's sort of, what is the point of this? Why do we do our jobs? And I'm not talking moralistically here. I'm talking about why are we literally there? Now, one answer is that it's to enable our customers and our users to be more awesome than they already are. Sort of one way of thinking about it. It's letting them do something far more efficiently, or letting them do something that they couldn't actually do before. Now, I wholeheartedly admit that I stole this question from my good friend Dan North, and this is his answer. He said, the goal of software is to sustainably minimize lead time to business impact. Now, the point is that we're not just here to deliver software. That is not our jobs. Producing a bunch of bits and bytes is not our job. We're not in the deliverables business. We're interested in outcomes. That might be the delight of our users and what they can do with our software. Now, lead time is interesting. And why is reducing lead time part of our goal? First of all, it gets this useful software in the hands of our users faster. That's good for them, and it's good for us because it should unlock some revenue, which is typically what we want to do. But it also lets us try a lot more ideas. And why is that important? Well, I'll get onto that in a few slides' time. First of all, just to dig a little bit more into this history, so how has software lead time changed over the years? So, as I said, I was first working on projects in the late 90s and early 2000s, and typically it took me then anywhere from, the projects I was on then, anywhere from 6 months to 2 years to deliver software. Now, that wasn't because we were completely useless. There were a bunch of constraints that existed in those days. So back in those good old days, releasing software was expensive. And it was expensive because of change management. It was expensive because testing was expensive, and a whole bunch of other reasons. And so because releasing software was expensive, we optimized our processes for large groups of people working on one product area with a small number of releases. Next up, infrastructure and the labor to manage infrastructure was also expensive. And so we optimized our architectures to reduce the total number of components that we deployed in a system. And we often used multi-tenancy of various configurations and customers into one big runtime. Now, it wasn't just that infrastructure was expensive. Changing infrastructure was expensive. We needed to use the same infrastructure, the same physical servers that we'd spent multiple tens or multiple hundreds of thousands of dollars on. We needed to use that infrastructure over many, many months and years for it to be cost effective. You wouldn't go and order a whole bunch of big Sun E4500 servers and then you only use them for a month. You'd get fired if you did that. So this fact that changing infrastructure was expensive is a big reason why traditionally our production infrastructure is mutable, why we can change what it does. And that brings a whole bunch of complexities around deployment. Now, all of these constraints drove us to a project mentality. And that's how we were traditionally working in industrial software teams. We needed significant technical, data, and organizational collaboration across large groups of people. And this led to processes like waterfalls and techniques like Gantt charts. These things weren't inherently bad. They were tools to help us work with the constraints that we had at the time. Now, over the years, those constraints have changed. Releasing software is not nearly as expensive as it used to be. We have practices like continuous delivery that allow us to optimize our build, test, and deployment processes through extensive automation. And we've also seen massive reductions in the cost of infrastructure and the management of that infrastructure through the maturing of public clouds. And because of these changes in constraints, we're now able to release software far more frequently. Continuous deployment of several releases is now something continuous deployment of several releases per day, strangely, is something that a lot of companies practice. So here's a quote. This is actually from nearly 2 years ago now, from a gentleman by the name of Sri Kote. He used to be the CTO at Comcast Cable. And I was in a presentation where he said this. He said, we used to ship our product every 12 to 18 months. This is, for those of you who don't know Comcast, they are one of, if not the biggest cable, internet, and TV provider in the United States. He used to say, he said, Comcast used to ship their product every 12 to 18 months. In a 3 to 5 year period, we shipped 3 or 4 releases. That was it. Now, and this was 2 years ago, we ship 3 releases every week. That's an extraordinary change. Now, along with this much, much more frequent release cycle, the lead time of an idea of what somebody wants to do within Comcast and how long that lead time is to actually getting it in the hands of the users has also drastically decreased because of this change. And now we often talk in our industry of lead time for features and new products in terms of days and weeks rather than months and years. And these reductions in cycle and lead times have changed how we approach software delivery already. So instead of focusing on projects and deliverables, we can now spend much more time thinking about the product that we're actually trying to build. Or in other words, instead of focusing on how many things we build, the output of our process, we can focus on the outcome. That is, how effective these things are in the hands of our customer. Now, a lead time of days and weeks is a massive, massive improvement of where we were against where we were 15 years ago. But we can do even better. Here's a quote from Adrian Cockcroft, one of my favorite quotes. Those of you that were in my workshop yesterday will know. So he said this about a year ago. Adrian used to work at Sun Microsystems for a long time. He was the main architect at Netflix that brought Netflix to the cloud. And now he's a senior person at Amazon Web Services. And he said this last year. He said, we're starting to see applications be built in ridiculously short time periods. And by ridiculously short, he means hours. He's literally going to customers where they can build an entire new little product in production in a matter of 12 hours, something like that. Now, as we reduce our lead time further and further and further, we can start focusing on a couple of really interesting points. First of all, we don't know up front what the best solution is for our customer. What we're making isn't something that we've made before. As Linda said this morning, building software products is a complex problem. We have complex adaptive systems. We can't solve problems. We can only sort of try various things out and see what happens. And when we start working on a feature or a product, we have an idea of what we're trying to solve. We have this idea, but there's a problem with those ideas. Most of our ideas suck. This is a quote from Jeff Patton, who's one of my favorite people in the product ownership and product management world. And this is a tough quote to hear, right? Most of our ideas suck. But it's true. Even though when we're working on a particular thing, or a particular idea, they feel great. It feels like, why wouldn't we be working on this right now if we thought it sucked? We think it's the right thing to be doing. We think it's the right thing to try. But history tells us that most of those things are never going to be useful. Most of those things might fail. And so if we, sorry. So history tells us that some of those things are not the right things to be working on. But here's the thing. If we have an environment where we can deliver an idea from scratch in hours, then we can try out many, many more ideas than we would otherwise try. And the thing about our ideas is most of them suck. Not all of them. Some of them are amazing. Some of them are going to be that killer feature that really helps some of our customers. And so if we can try enough of these ideas out, we can play a numbers game. We can say, and we are far more likely to come across a winner the more ideas that we try and find that idea that's going to really help our customers. So we've already decided in our industry that pretty much, in fact, every company is a technology company. We hear this about some of the massive, massive industrial companies in the US who now, I think companies like General Electric, who make jet engines and massive medical devices and all kinds of things. General Electric now consider themselves a technology company. And we hear about all these other massive companies like Ford and whatever who consider themselves technology companies. And the reason that they've made that shift is they know that if they don't consider themselves a technology company, then a new technology company will come along and just blow them out of the water. That's what disruption is all about. But to me, to be a technology company is not enough, right? And enterprises need to now start thinking about how they can embrace experimentation as their core system of work, as the way they do day-to-day business, not just something that they do once a week or so. Now, startups have been thinking in this way for years. Some of you here will probably have read The Lean Startup. It came out quite a few years ago now. One of the things that The Lean Startup does really well as a book is defines a language that lots of us can use. It's sort of a core language. And so companies that are embracing the ideas from the Lean Startup, they build minimum viable products, they assess whether those products are successful, and then importantly, they keep pivoting, they keep trying new ideas until they find an idea that works. That's the whole premise of the Lean Startup. Now, enterprises can also start thinking this way now because of the much shorter lead times that come from these new ideas in software development. So in summary, we need to stop thinking about our software organizations as feature factories. And this is really the mindset of the never-ending backlog. We look 6 months out and we just plan the next sequence. Because that way of working, even if we think it's agile, because we're having another iteration planning meeting every week or two, that way of working is still a remnant of working in a project-based, output-oriented environment that's optimized, frankly, for few releases, even if we are releasing very often. And that system's out of date. Instead, I think that we can transform our organizations into product laboratories, embracing an idea of continuous experimentation. And this is going to allow us to build products that can make our customers even more awesome than they already are. Yay! There we go, job done. Have a nice rest of your day. It's not that easy, is it, really? There's a few challenges that come with this. There are many, many challenges that come with this. Otherwise, we'd all be doing it now. So how do we get our companies to this wonderful nirvana of continuous experimentation? Well, I think I could talk for weeks on various challenges, but I've got 9 for you, just to get everybody started. And I want to talk about these challenges, then don't worry, I'm going to talk a little bit about how I think that we can solve some of these things. And some of these challenges are technical. Not all problems are people problems. So that wonderful thing was, as soon as you're an engineer and you start becoming a manager, you go, oh, all problems are people problems. And you go, well, most problems are people problems. There are some things that are still fundamentally what is a technical platform that we have available to us. So some technical challenges, but there's also a number of organizational and cultural issues that we need to address in order for continuous experimentation to work. So on the technical side, we need to minimize incidental complexity. We really need to be able to just focus on the complexity that is around the particular experiment that we're trying to solve. So that's things like, and all that sort of cruft that comes along with building an application. Oh, we have to set this up, we have to set up user management, blah, 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 blah. Like, we want to minimize all of that stuff. We want to focus on what is the core of what we care about. But there's a reason incidental complexity exists. We still need to have valid, safe production systems that we can deploy at scale. But we want to maximize the amount of engineering time that we can on just the core problem. We want to reduce our infrastructure costs. And we want to reduce our commitment on deploying a brand new system. So an experiment might only last a couple of days. And so we don't want to lock ourselves into an expensive system. To precisely use Linda's words from this morning, which I copied and put on this slide in between, like, we want to have infrastructure that is small, simple, fast, and frugal. We want to be able to bring a whole bunch of stuff up, and if it doesn't work, tear it all down again. And that shouldn't be a problem. And the final technical challenge is we want to minimize the technical debt impact of a highly fragmented ecosystem. So we want to reduce all of the technology overhead that might come from having lots and lots of different experiments. So we're going to have lots and lots of small systems. And how do we have sufficient decoupling between those things? OK, so let's look at some more organizational and cultural issues. First of all, we want to minimize the time it takes to go from our code being ready to it being deployed for the first time. And there's a bunch of technical and process-oriented problems there. We also need to change the culture of our organizations to encourage continuous learning. So we're not going to be doing the same thing repetitively over and over again anymore in a feature factory. We have to learn so many things about what we're doing, both the problems that we're trying to solve and the ways that we work. And finally, product innovation needs to be spread around teams. It is not just the responsibility of product managers anymore. If we're constrained by what our product managers can do, we're never going to move fast enough. And so we need our whole teams to be thinking about ideas so that we can move fast enough. A final set of challenges that I sort of think are as important as those others are challenges around safety. So this is going to be a much less structured world than we're used to. And so we need to rethink about what safety means. So we need to have an environment where it's safe to fail. We want it to be psychologically safe for all our people to be working in this way. We need to maintain budgetary safety in a significantly more dynamic environment. And we also want to maintain appropriate security and data access safety. So these aren't the only challenges, but they're a good set to start working on and start looking at. And I want to sort of give you some ideas about how I think about some of these challenges. So first of all, I want to talk about the technical challenges. And I think that the brave new world of serverless has a lot to offer around these technical challenges. So just to give you a little bit of a background, so one of the reasons I started speaking more and doing consulting was I became really interested in these serverless ideas. I'm not normally one to jump on a technical bandwagon, but this stuff really, really struck a chord for me. And I started getting really into them about 2 years ago, and I wrote this article on Martin Fowler's website, which proved to be very, very popular and sort of was one of the launch points of my business. So just to give you, for those of you that sort of don't know too much about serverless systems, a very, very quick reminder. Serverless services, the kind of things that we can use when we're building serverless apps, are things like Amazon Lambda, Google Firebase, Auth0, which allows you not to have to program all that user management stuff that I said we wanted to avoid. Amazon S3 is actually a good example of a serverless service, and also things like Amazon DynamoDB. I do about 95% of my work on Amazon, which is why this is a bit Amazon-oriented, this slide. What makes these things serverless? Why are these products in particular serverless? So I have sort of 5 criteria that are sort of define a serverless product, of which I'm going to mention 3 that I think are important to what we're talking about today. So first of all, serverless services require no management of server hosts or server processes. Serverless services self-auto-provision and auto-scale based upon the actual load that is being used with them. And they have costs that are based on the actual precise usage of those systems, not something that we've pre-planned or committed to over a long period of time. So there are other attributes, but I'll leave that to another time, and you can look at some of the links that I give at the end. So why does serverless help us? So the first challenge that I talked about was minimizing incidental complexity. So first of all, a number of serverless services provide us pre-built generic logic that we can use in our own applications. And this is things like Auth0 and Amazon Cognito that handle all the user management that we would otherwise have to code for ourselves. And another extreme, it might be something like Amazon's machine learning service. That means we don't have to build our own Spark models and something like that. Serverless provides an extremely lightweight model for custom code. Those of you that were in the workshop yesterday will have seen that you don't have to extend any framework or use any framework when you're writing AWS Lambda functions. You implement a very, very small piece of code that just has a particular type of signature. You don't have to use any AWS libraries at all. And we see this lightweight model in functions as a service across all the other functions as a service providers. So Google Cloud Functions, Microsoft Azure Functions, and a bunch of others as well give us this very lightweight model. We're not thinking about big heavyweight frameworks here that take days and days to set up. Serverless handles system administration for us. That's a significant part of our operations work. It doesn't handle all of our operations work. We still have to think about monitoring. But a lot of this idea around sysadmin for compute and for data storage and networking, all of that is handled on our behalf when we're using serverless products. And finally, serverless has automatic horizontal scalability without any significant effort on our part at all, and sometimes without any effort on our part. And this is really important because our experiments are often not going to be valid experiments unless we can test them at real scale, right? Sort of go off my notes a bit and sort of, again, speak to Linda's point this morning. Like, unless we're actually having randomized test groups and we're having the amount of data and traffic that we can get those randomized test groups, we're not going to be able to sort of get good information on our hypotheses or not. So that's the first technical challenge, minimizing incidental complexity and how I think serverless can help there. Next of all is we wanted to reduce our infrastructure cost. So remember, what we're looking for here is to reduce both the actual cost of infrastructure, but also to reduce the commitment that we have to put into building an entirely new system. So with serverless, we have very little overhead cost. And as I said, most of the costs that we have are based on actual precise usage. If we want to tear everything down after 2 hours, it's no big deal, and we don't have to pay anything after that period. So the wonderful thing is that costs will scale up as our systems scale up, but costs will also scale down as our systems automatically scale down. And this is very important when we're thinking about this experimentation-based workflow. And finally, in traditional systems, it really makes sense from a cost optimization point of view to co-locate multiple features into one system. But that brings a bunch of complexity. Because now any new work has to tie into an existing application when you're working in that way. Now with serverless, all of this goes away because costs just don't work that way in serverless. You pay for when your system's actually doing something. That could be one big system or 10 small systems. You're paying the same amount whatever you're doing. Now this is a huge change, and I don't think it's one that even those of us that are deeply swimming in the serverless ocean have really grasped yet how different this model is of thinking. This is a very different type of constraint of architecture. But it's definitely going to help us reduce our infrastructure costs when we're building many experiments that we want to be somewhat independent from each other. And our final technical challenge was we wanted to minimize tech debt. So serverless really encourages a modular, well-encapsulated, loosely coupled architecture. Now, don't get me wrong, if I told you that serverless is the answer to all our problems and I can give you 3 books that tell you what great serverless architecture is, I would be completely lying. And if anyone turns around and says they have a serverless best practices architecture book anytime soon, they might not. We're still really learning what good serverless architecture looks like. I think there are some good ways, some pretty well-known ways of operating serverless apps now and sort of lower level sort of basics, but what an entire serverless application looks like, we're still sort of really figuring out. But we do know that it encourages this sort of modular, loosely coupled system that we need to avoid all these tie-ins between lots of things. For those of you that are really interested in serverless, if you're only using serverless for the cost savings, I think you're really missing a big trick. Serverless is, to me, much more interesting because of the speed advantages that it gives you in building new systems. OK, so that's serverless. That's a technical platform that we can use as our experimentation platform. But a technical platform is not sufficient. Our organizations need to change too. So continuous experimentation is about both continuously delivering new implementations to try out tests, but also about making those tests provide ever more value to our users. And so how do we need to change our organizations to make this happen? So the key lever, I think, as we start thinking about organizational concerns is DevOps. But what I'm specifically talking about here is DevOps culture. So when I'm talking about DevOps here, I'm not talking about a bunch of automated Puppet and Chef scripts that are checked into source control. Those things are great, but they're a tiny part of DevOps, and they're not the part that I'm interested in right now. I'm talking about how do we bring development and operations and a whole bunch of other engineering activities much, much closer together rather than having those activities performed in strictly siloed organizations. So that some of you will have come across this book, the DevOps Handbook. It's actually downstairs at one of the vendor stands. I recommend going and checking that out. I think this book is one of the most important books in our industry of the last 15 years or so. I am biased because of the way I think about software engineering, and it very much fits my world. But I read this book, and I learned a ton from it. I used it a lot, actually, as I was sort of going through and thinking about these ideas. And so I really recommend checking this out. So how does DevOps help in our challenges? So DevOps has already done a really, really good job of improving our cycle time. So DevOps is part of the continuous delivery world. And especially as it allows our teams to practice beyond continuous delivery into continuous deployment. And those techniques are absolutely useful for us in continuous experimentation world, but we need more than that. We need to improve our zero to production time. So continuous delivery is great once you've got it up and running, but how do you get a new product up and running in continuous delivery? So let's remember what we're trying to do here. We're saying that we want to build brand new systems, not evolution of current ones, brand new systems within a few hours. And much of that time is going to involve coding. So that leaves us very, very little time to launch our software. Maybe an hour or two, maybe just like 20 minutes or half an hour. How can we go from our very first cut of our code to deployed production system? Now, in order to do this, we need a lot of automation to bring up new systems, and we need to have a platform that's going to react to these kind of sort of requests that we're going to make of it. Some of this is going to be provided by serverless. Some of it might be provided by a really great container platform. But we also need process and culture as part of this. It doesn't matter if you've got a technical platform that supports this rapid deployment. If you've got a process and a culture that says, no, you've got to go through a whole bunch of gates, then we're still not going to work. And so we need to move beyond continuous deployment to getting our organizations to think about how do we bring up entire stacks of components very, very quickly that are brand new. So there's no point in having continuous experimentation if we're not also continuously learning. And a big point of each trial or experiment is the feedback for figuring out what our next trial or next test is going to be. But oftentimes, that's not really the way that we tend to work, right? When we're engineers that are working in feature factories, we take our requirements that are come down on the big almighty backlog, and we crunch them up with the same old techniques that we've been using for a long time because we're under time pressure, and then we just repeat that. But now we need to place learning as important as delivery. And this is a change, and it's going to come in various forms. We need to be learning about our customer. What does our customer care about? We need to be learning about our tools. If we're going to be producing systems in this amount of lead time, we're going to have to understand our tools and understand the capabilities of new tools as they become available. We also need to learn about each other. Like this is not going to work if we're a bunch of individual person islands just trying to do our own thing. Like we have to understand how to work as better teams. to move this quickly. And so that means we need to learn about each other. And that's some messy people stuff there, right? But it just needs to happen. Like what is the skills of each people? What are the things that other people aren't so interested in? How can we trade off each other? That's an incredibly important part of this learning as well. So first of all, to sort of get to here, we need to change our approach to management. To start with, no longer is it useful to build backlogs of work 3 months or 6 months or 9 months out and track progress to that as whether we're being effective or not. Like, we need to continuously learn and adjust what our product needs to be. There's no point using that 9-month backlog if we've learned a whole bunch of stuff in between that makes 80% of that irrelevant. But it's not just on management, it's also on us as engineers. When we're in the process of writing code, what are we optimizing for? So writing the perfectly designed, highly efficient solution isn't necessarily the most appropriate thing to do when we're trying to learn about a technology or we're trying to learn about a customer's need. And sometimes copying and pasting code is actually the best thing to do, as long as we commit to stabilizing it at a later date if it proves valuable. And mostly what we want to do in experimentation mode is the smallest amount of work that we need to do in order to test a hypothesis. Now, my friend Dan North has been doing an amazing amount of work with these ideas for quite a few years. And there's a video in one of the links called Software Faster, where he talks about this. And I really, really encourage you all to check that out, because there's some amazing ideas in there. He also says he's going to write a book, which many of us are hoping for and looking forward to. But it's also the whole team's responsibility to change how we think about ownership. So I think that product management now needs to be a mindset and not an individual. And the most effective engineering teams are the ones that consider customer affinity. It's the idea of what do our customers want, and not just the best technical solution. Martin Fowler wrote a blog entry about customer affinity for engineers nearly a decade ago. And I think it's a massively, massively important thing. Now, not every individual on a team needs to wear every hat. But I do think that we need to break down the silos of roles across software delivery, even within a team, including the non-technical roles. I've seen many, many developers excel in this area. And in fact, I think when we treat engineers as just code robots, we're not really releasing their full potential. So that's sort of some of the stuff around process and management and culture. But there's this whole other area of safety. And as we change product development from being a project process of a regular cadence over time that everyone knows to one of continuous experimentation and feedback-based sort of redirection and sort of trying out new things, we need to drastically change how we approach risk and safety. Experiments are going to fail. Products' expectations are going to mutate. And the requirements of our technical environment may change drastically and quickly. But safe experimentation is not a contradiction. That idea is not a contradiction. We can have safe experimentation. That's what science labs do all the time. And so how do we have safe experimentation in our product labs? So first and most importantly, we need to allow our people to feel safe by creating an environment where failure is not something to be scared of. Now, Google figured this out a while ago, and the New York Times had a great article about Google's own introspective studies and included this quote. Google's data indicated that psychological safety, more than anything else, was critical to making a team work. This might seem reasonable, but how much effort do we really put into this in our own organizations? Now, the best companies, even those that sometimes we think might be surprised about, adopt failure as part of their process. And here's a quote from Jeff Bezos, CEO of Amazon, on the Fire Phone, which was, some of you may remember the Fire Phone as being a complete failure. And someone said, wasn't that a big failure? And Jeff Bezos replied, if you think that's a big failure, we're working on much bigger failures right now. And I am not kidding. So if we value experimentation, we've got to actively embrace failure as learning. and not just merely treating it as an unfortunate side effect. I was really interested by what Linda was saying this morning about maybe not even using the word failure. So how do we go about making our cultures ones in which it is safe to fail? So one idea is just to start with blameless postmortems, or learning reviews, as sometimes they're called. And this is also in the DevOps handbook. There's a big section in the DevOps handbook about blameless postmortems and psychological safety in general. So that's psychological safety. But I don't think it's enough just to think about the safety of our coworkers, although I think that is the number one. We also need to think about the safety of our business itself. So there's several areas that we need to think about here. We need to think about infrastructural budget and how do we make it safe to create whole new stacks of software on a frequent basis without completely bankrupting our business from a ginormous AWS bill or Microsoft Azure. So we need visibility and ownership into our costs. And we need automation and tooling so that teams can know how much they've spent on a daily and a weekly basis and incorporate that into how they work. We also need data and security safety. How do we get that when we're changing so rapidly? We need to make it part of every team's regular work. So I think that security is part of engineers owning operations as much as anything else. But in order to do that, we need to also give them the tools they need. So we need to build shared tooling across an organization in a way that protects data, but also gives enough flexibility for experimentation. Where possible, we want to give team autonomy of many access controls, but building review and exposing changes as part of their system of work. But we also need to actively update our cross-organizational change request processes to optimize for flow when team autonomy alone is not always going to be the best thing or not always going to be sufficient by itself. So that's sort of all the 9 challenges I've discussed. But there are many other areas to consider in this whole idea of continuous experimentation when it's such a drastic change over how we've worked before. And I do think we have a lot of the tools that we need, and we're all smart people, and we can figure out what the rest of the other challenges are and how to solve them. But how do we go about solving those? And what about the questions that we haven't yet asked, let alone answered? And what is our framework for figuring out what those problems and what those questions are? So one thing I've found useful over the last couple of years is this idea called modern Agile. This is from a guy in a company called Josh Kerievsky in Industrial Logic, based out in California. Josh has been part of the XP and Agile, extreme programming and Agile world for a couple of decades. This is the entirety of modern Agile. No, you can't get certified on it. And there's no more to it than this. But I think that these ideas of making people awesome, experimenting and learning rapidly, delivering value continuously, and making safety a prerequisite, if we're sort of placing these values at the core of how we're trying to work, they're a good way of surfacing questions and how to maybe approach some of those problems. So that's at modernagile.org if you want to get that. So I think that if we combine serverless with these ideas from modern Agile, plus DevOps as a culture, plus all of Dan's ideas about software faster, how we can really crank out code, but in a responsible way, we can get to this idea of continuous experimentation. And I hope what I've shown is that the ability, we do have the ability here to go from idea to production in hours. And that's the thing that's most exciting to me. I've seen organizations do this, where they had almost infinite money, and they had one of the smartest developers I've ever worked with. They were able to do this. They were able to have an idea at a stand-up meeting in the morning and have it deployed in production in the afternoon. It is not impossible. But that was a unique set of situation. That was a unique situation. How do we make that something that we can all do? Like 10 years ago, we would have said the idea of companies deploying 50, 100, 200 times a day would be ridiculous. But it's not ridiculous anymore. Many companies are talking about it. And I think if we get to this point of this idea of continuous experimentation, it's going to change a whole idea of how we go about product development. So serverless provides us with a technical platform to do this, but it alone is not sufficient. Modern Agile provides a value framework. DevOps is providing our principles and our practices. And I said Dan's software faster ideas really provide sort of patterns for effective engineering teams that allow us to think about how we actually go about the actual act of software engineering. So all of this sort of comes to a question. How are you going to transform your organization from a feature factory to a product laboratory? And thank you very much. So I promised you the resource link. That's the resource link. So all the quotes are there. The slides here are here as well. I'd love to chat. I'll be around for the rest of the afternoon. And I am Mike at Symphonia.io, and happy to chat to you online. And this is literally what I do for a living. Thanks a lot, everybody.